That's great.
We're good to go.
Okay, great. Thank you so much for the opportunity to present. So I'll enable cameras. So if you can enable your camera, I will deeply appreciate it. So I can see your reactions to what I'm saying. Also, please interrupt me if you have any question. No question is wrong. All questions are valid, and we are all curious. So what I'm looking for is to try to show you what I like and what I'm working on, and perhaps you are also interested in similar topics, and we can collaborate and discuss further. So as Rajshri said, my name is Daniel Acuña, but you can also call me Daniel Acuña. Both work. I'm an associate professor, well, visiting associate professor. I hope that they like me and keep me for the next semester. And I guess a little bit about myself. I was in Syracuse University in information school department, which is a little bit more kind of it's like a business / computer science / human-centered AI program. So I mentioned that because I have a very interdisciplinary background, and I'm interested in many, many topics, perhaps too many topics. So I'm always curious to discuss any of these things. And I hear someone. So let's see. I think someone's.
So we'll have to request everyone to mute themselves, please, as you enter the room.
Yeah, thank you. Okay, so but my background is in computer science, and I always love the technical challenges that we're able to solve with our knowledge and tools. So I'll just get started. So the topic that I will present today is artificial intelligence for scientific discovery. And this is one of my primary interests right now, but I'm interested also in trying to understand science itself in a field that is called science of science. But today I will talk specifically about this. And again, I'm looking for a student. So I will present two projects. And at the end, I will talk a little bit of some projects that I'm looking help with. So perhaps you find those projects interesting, and we can discuss further. Okay, great. So again, if you have any questions, feel free to interrupt me and ask, and unmute yourself in the chat, whatever you like. So I run here the Science of Science and Computational Discovery Laboratory in this brand new place that I cannot show right now, but it's behind me. It's in the North Tower. It's very beautiful. If you get the chance, please visit us. The work that I will present, I couldn't have done without the help of PhD students, dozens of master's students, and funding that allow me to carry out some of the computational work, and also hire students, and also many, many collaborators that cannot possibly list here. So I want to get this out of the way. None of this would be possible. None of this will be possible without the help of these entities. All right, so what is this thing about science and AI? Okay, so I'm very interested, I'm fascinated really by science itself. Like science, if you think about it, is one of these pillars of modern economies, of modern societies, where it's basically like the research and development of modern societies. So it's like the way in which we create new knowledge. And the US and Europe and in Asia, we have these powerhouses that are adding to what we know about how the world works, how discover new things about mathematics and all kinds of stuff that are very interesting. Now, one of the things that we rarely discuss is that the return on investment, if you think like an economist, the return on investment on scientific investments is really, really high. It's around 5 times. So if you invest $1, you get $5 in return in social benefits. Okay, so anytime you see the National Science Foundation, the National Institute of Health investing in a new camp for scientists, or in a new treatment, exploratory treatment for cancer, the long-term effects of that, think 50, 100 years, is 5 times what they invest. So it's an extremely powerful tool that the government and foundations and private entrepreneurs have to advance society. So I will talk a little bit about a cartoonish view of how this process works, how this scientific process works, and how I think AI can help in many of those steps. So the scientific process of knowledge production works more or less like this. We have scientists who are studying what we currently know. So they go into libraries, and they browse the web, and they try to understand, okay, this is the boundary of our current understanding of how the world works. Okay, so there is a step that I call knowledge discovery. Then after that, there is a step of selecting which problem to attack, right? So there are many problems, but of course there are problems that are more interesting for us, or that perhaps we predict to be more impactful in the future. So that's what I call innovation prediction, which is a combination of impactfulness or impact and novelty. We want to pursue something that is very novel and also has the potential to have a real impact in the world. After we work on the project, we want to show it to others and check if it works and if all the steps are correct. So we want to publish correct science, and we do that through a process called review or peer review. So in that step, we submit it typically to conferences or journals or peers, and they review it, they see our methods, and they try to reproduce them sometimes, or try to kind of follow the steps, maybe re-execute the code with different data and things like that. And they say, it passes the basic checks. Okay, so any question about this? All good? Okay, great. So again, if you have any questions, please feel free to just unmute yourself and chat. Now, what's interesting, I think, and what is really kind of drives my work is that many of the steps that I showed you before, discovering what we know, trying to select which problem to work on, and then reviewing the work of others, is very manual. It's very labor intensive. So it's all based on other scientists, on humans, basically. But if you look at the time that we have available as scientists to devote to these steps, is really small. So if you look at the kind of a survey of the time that we spend per week, you can see that writing a manuscript or doing peer review or reviewing the literature is just a tiny part of the time that we have available. Also, when we do this review by hand, we're opening ourselves to all kinds of potential biases, because we're all biased, we're all humans, and we like certain methods, we like certain approaches, maybe we like certain groups of scientists, and then we have a bias in how we select what to work on. So how can we help? Well, there's been really, I would say, a nascent field called AI for science, or the automation of science, or machine science. Is this idea of trying to automate processes that historically have been done by fellow scientists. And there was this, I would say, groundbreaking paper around 13 years ago in the journal Science that talked about this, and that presented many papers that tried to do this, of building automated methods to discover new knowledge. We've had recently another article in the journal Nature, which is one of the top journals in science, talking about how labs are now using AI to understand protein folding, for example, which is a very complicated way in which the body works. Every protein in our basic proteins form these little machines that work inside our body, and for a long time we don't know how the instructions transform into these 3D machines that do all kinds of things inside our body. So, but now with AI, we can predict very well how the instructions transform into these 3D machines. So we are able to kind of predict what are the things what is the kind of space of possible machines that we can have inside our bodies. And this opens up all kinds of possibilities for developing new drugs, new treatments for diseases, and etc. If you are in computer science, you know that one of the top conferences in the field is NeurIPS, and they have a workshop. They've been having a workshop every year since the last 3 years about this idea of using AI for science. And there is a workshop this year. The deadline is in a couple of weeks about this very issue. Recently, there was another paper that showed that you can develop methods to try to kind of from data only uncover potential laws of physics And this is one of the groups that is trying to do that, and is very effective at kind of plowing through enormous amounts of data to try to uncover these very basic laws of how this data set works. There was an article in Quanta magazine, it's a very interesting magazine that kind of goes into more depth about these advances. Now, there are some companies trying to take advantage of these new developments. There is a very interesting company that has this website called Elisa.org, where basically you put a query such as imagine like Google, but instead of asking just something that is already present in the web, you ask a question, and this website understands the question and then it goes through the literature, it tries to answer and tries to gather information and evidence to answer this question. So, for example, if you ask what are the cures for COVID-19, it will try to go through the literature and pull information about this to answer this question. And there are labs trying to do this. Microsoft is very interested in this. So there is a lot of interest. I hope that you can get that from these slides. There is a lot of interest trying to understand this topic. So in my research, what I'm trying to do is to try to exploit the kind of the basic medium by which we transmit new information in science. So the data that we have in science, one of the most important data sets are papers, basically scientific papers that are published in conferences and journals. So this is a typical paper, and this is from a website from the NCSU University that kind of explains the different pieces. Now, what's interesting is that most of the knowledge that we have about science is explained in these papers, but they're meant to be read by humans. So we cannot really say, okay, give me all the equations that relate, this quantity with this other quantity. There's no way of querying this. There's no way of trying to access all the tables or the data that is inside these tables, for example. It's all human readable. So this opens an enormous number of potential applications to extract knowledge from these publications. And I would show you a couple of these potential applications. So one of them, the most obvious, is try to do all kinds of natural language processing on this data set. So we have titles, we have the authors, we have the institutions. We can do things like name entity recognition. We can try to recognize what the article is talking about and how these entities are related, and perhaps start answering questions with question answering systems. We can also start embedding concepts here. So from natural language processing, we can kind of have vectorial representations of concepts. I try to understand how they map into a space of potential concepts. So here I'm mapping millions and millions of articles. And if you, it's kind of hard to see, but basically the colors here indicate how they are positioned in an embedding space. And from the NLP representation this is just applying BERT to the abstracts, we can see that they cluster very well according to the topics that they're talking about. We can also look at the references, so we can see how the papers are talking to each other, how they're related, and from that we can apply all kinds of new techniques. There is this new field or new kind of application of neural networks to graphs. So we can start doing embedding in graph space and prediction of links, perhaps citations that are missing and things like that. From the figures, all of this is meant for humans to be read, but we could apply computer vision to the figures and try to pull apart the different topics to kind of extract information from graphs and things like that. So there's a lot of information embedded in the scientific articles, and these techniques from AI, it's a sample of them, can help us to process them. So again, if there are any questions, please feel free to ask and mute yourself. Now, another very interesting phenomenon that has been happening over the last 10 years is that historically the data has been closed. So the data to access the articles and the citations have been closed and are expensive to access. But recently, companies have become interested in mining this data and making it available to us. So Microsoft has been interested in this. The National Institute of Health is opening all the open access publications. So we have access to billions of publications, everything about them, the data sets, the full text, the images. And as you know, AI relies on big data sets. So these are very large data sets that they are waiting to be analyzed by us. So I'm very excited for this development, and there are just so many low-hanging fruits in this space. Okay, so let's kind of pause a little bit and kind of think about the kinds of questions that we can ask. And so to me, there are kind of two dimensions in the kinds of questions we can ask. At the first dimension, we can say, okay, we can do different kinds of levels of analysis. We can go from simple correlations, from trying to understand how science has been done in the past, to optimizations, to think about, okay, how should we do science? What are the optimal ways of doing science? If you can think about it, like what are the ways in which we should write papers, the best ways in which we should review others' work, and things like that. Now, in the other dimension, we can try to think about the different steps of the scientific process. I talk about how to discover the knowledge boundaries, then how to think about what problem to choose from of that vast boundary, and then how to detect potential problems or review the correctness of those results. So we can think, in these two dimensions, and each of these cells here, to me, represent very interesting problems that I'm thinking about. So I will talk about two main projects, and again, after this, I will list some projects that I think I'm immediately interested in someone to help me solve them. Okay, so recommender systems and assignment systems for science. So this idea that we go to a library, I don't know if you've been to a physical library, but in the past, we used to go to libraries and browse scientific journals and discover what's available there and what are the kind of the boundaries of what we know. And it was relatively easy. You will go to a library, a librarian already had sorted things for us. So the journals, I mean, physically, I'm talking, the journals will be nearby, things that are related to each other will be nearby. So it will be relatively easy to find similar things. But now everything is virtual. So how do we do it? Well, the way that we discover new content, if you think about Netflix or you think about YouTube, they have recommender systems. So when you go to those websites, they think about what you would like in the past and they try to suggest things that are related. So we could apply the same concepts to science. Now, many people have thought about this, of course, and we have many search systems that do this, but the problem is that many of them are closed source, so we don't know really how they work. And one of the things that we should do in science is try to open things up, to try to kind of make everybody have the possibility of accessing this information. So I kind of don't like too much that these systems are closed. So we develop a system that is a recommendation system based on the content of the articles, and it works with a very simple algorithm. And if you compare it to what the big companies apply, it's much simpler in comparison, but it's just opening so much possibilities for how we discover knowledge. So the basic idea is to extract from a library of, we are using around 30 million articles. We use the abstracts. We compute a very basic representation, but it's very powerful indeed. I mean, it's basic, but it's very powerful. It's a representation called latent semantic analysis. And that basically gives us a vectorial representation of an article. And then what we do, we ask the user to give us feedback on what they like and what they don't like of certain publications. Basically, then the system takes our preferences. So let's say we have our green will be things that we like, red will be things that we don't like, and then it recomputes a vector that is based on those two things. And is able to also, of course, take multiple votes into account. And then it just basically recommends articles that are nearby, again, based on this vectorial representation. We made several tests of this. So basically, we show that our representation, it makes sense. So basically, things that humans consider to be nearby are going to be nearby in our algorithms. Things that humans consider to be far are also going to be far in our algorithms. So it's kind of correlated with how humans think about things. Also, we show that it learns. So the more feedback you give, the closer it gets to what humans would recommend. So that's good. It's another test. But one of the things that I'm also very interested about is to develop systems. So we have this theory, we have the papers that we develop, we show that the algorithm works, but I also love to develop systems that actually make users try these algorithms. So we developed this recommender system. I think, unfortunately, at the moment, I think this website is down. We're hopefully opening up for next week's presentation in the information school. But it's a system that basically takes this idea that is presented and give it a form in which people can try it and see if it works. So here, for example, is recommending kind of deep learning with COVID-19 applications. So it's recommending things that are related to that topic. So I'm going to skip a little bit of this. We took the same idea and we developed automated assignments for scientific conferences. There are many conferences already using our system, so we're able to match reviewers to papers and kind of maximize the affinity of the users with the affinity of the papers with the reviewers. So this has been incredibly helpful, especially for very big conferences that have 15,000 submissions. Okay, so the second case study that I will talk about is something that I call computational research integrity. And it's basically, if you have studied computer vision or forensics, this is media forensics applied to science. Now, this is a little sad, but I will talk about kind of a bad component of science. So there was this case a couple of years ago of a scientist who claimed that you can replace the trachea, so this part of the body of someone, with an artificial component, with an artificial, something synthetic. Of course, if you put anything synthetic inside a body, it's going to reject it because it's not part of the body, so the immune system will reject it. Now, this scientist claimed that if you put stem cells into these devices, into the synthetic devices, the body wouldn't reject it. Now, unfortunately, all of this was based on fraudulent results. And most of the patients that this person operated have unfortunately died. Now, the way in which the fraud was detected was through the images. And what happened is that many of the papers of the scientists, which were breakthrough papers, have duplications in them, and they have fraudulent reuses. So one of my goals is to develop methods to detect potential manipulation of scientific figures and potential detection of duplication in this aspect. Now, again, the way that now this is discovered is through basic peer review. So we have humans going through the papers manually, or whistleblowers, the community, or there are agencies in the US that do this, but it's all manual. It's very slow. It's also inaccurate. And sometimes if you are a whistleblower, it can be dangerous for you. You're risking your job. So there are many downsides. So how can we do this automatically? So I took ideas from forensic science, and basically I said, okay, we can develop, I used just the basic recipe of AI. We just need data of things that are fraudulent, not fraudulent, and we will apply a computer vision system that will extract different pieces from these images and try to decide if they are fraudulent or not. So I kind of want to skip through the details here, but basically we got around 2.5 million images. We labeled some of them, and we developed a computer vision system that will go through them and detect the different pieces of the images, and I will train a classifier that will say, okay, this piece here is the same as this piece here, and is very suspicious. There are some very suspicious reuses, so it will flag them. Okay, so I will show the steps here. This is a scientific figure. It looks normal to the human eye, but if you start looking at it, at first we'll extract some key points. This is just basic computer vision techniques. I'm going to skip through this, but basically we need to find similarities in the space. So these are the similarities that we found, and you can already see some clustering. So there is some, this panel here is very similar to this one here. And there is some post-processing, some classification, and in the end we get something like this. It says this panel right here is exactly like this one, this panel right here is exactly like this one. And this is we will give to a human judge, and the judge will tell, will label and give us feedback of how we are doing. So these are some examples of what we found. So these are things that are reuses. It works across images, across the same paper, or also across papers. And it's robust to all kinds of manipulations of rotations, changes in colors, and things like that. So these are some examples of what we found. So we found thousands of cases, and we're going through them at the moment. But basically what we found is that there are a lot of cases out there, and if we can apply something like this, we can improve science by just selecting, doing some filtering. We have done other work in computer vision with images as well. So we are able to detect potential violations of certain graphical principles. I'm going to skip through this, but basically we're applying, we have images, we apply several steps of deep learning techniques to extract panels, to classify different kinds of panels, and then do OCR on the images to try to understand whether they follow some principles. And we found around 5% of the publications have some serious issues. All right, so I'm going to close the kind of showing you the work that I've done by saying that there is a lot of potential opportunities for using AI. Most of the science that we do today is very labor intensive, but AI has made so much progress in natural language processing, computer vision, graphs, that we can use those techniques and apply them to science. We can accelerate how we discover new knowledge. Data sets are appearing every day, and I think we have the opportunity also to increase the data set that we make available. So in my lab, we also create our own data sets and we make them available. So we recently released a data set of mentorship in science, and there are already papers using those data sets. So I'm looking for some help on the following projects. So I have already a couple of students working on this particular one in this slide. So one of the things that I'm interested in is trying to help scientists write papers. So we're trying to build a system that will kind of complement how scientists are writing papers. It will automatically, suggest papers that you should cite in a certain article, in a certain sentence. And also it would suggest papers that you should read before you start writing the paper. So let's say if you provide an abstract, this system will ideally provide a list of papers that you should read before you embark into that particular idea. And again, we're using the same techniques that we're using in computer vision, in NLP, transformers. In this case, we use this for an oral paper. We use an LSTM, bidirectional LSTM, and it has remarkable performance. I'm also using I'm looking for some help with computer vision. So not just detecting duplication of scientific images, but also manipulation of scientific images. And I have some work in this. We developed some techniques to detect potential manipulations. It's extremely good compared to other techniques. And it's because we are kind of adapting them to the scientific field. So in science, the images are very different from the images that you see in other computer vision applications. So there's just a lot of work that we can do in this space. So I'm looking forward to what my students will do in the future. More generally, I'm also looking for ways in which we can quantify innovation. So if you think about it, scientists are trying to discover new ideas that are novel. So we're trying to use NLP as well, or embedding, to try to understand the distribution of potential ideas. So this is applying outlier detection or novelty detection from AI, but to scientific documents and to text. So I'm also very excited about this line of research. Now, something that I'm also interested in is this idea that lots of the data that we have is based on past ways in which we did science. Okay, so it's things that is based on ways that we did science, 10, 15 years ago, and many times they contain many biases. So here we have done some basic tests of how biased scientific terms are. And as you can see, let's say we try biases against female and male names, biases against Black names, African-American Black names, and European-based names. And basically what we found is that there's a huge bias against female concepts, female names, and there's a huge bias. It's a very consistent bias against Black names. So we have a lot of work to do in trying to correct these issues. Yes, I'm saying we should use data to try to improve science, but we also should be mindful of the potential biases that this data might have. And with that, I will finish my presentation. Thank you so much for the invitation, Rajshri, and I'm looking forward to discussing. If you don't want to ask any questions, that's fine. You can send me an email or look more information on my lab in this URL. Thank you.
Thank you, Daniel. So if anyone has any questions, you can unmute yourselves and ask, or can even post it on chat, and we'll try to answer those for you. And as Daniel said, if no questions, we're okay with that.
Oh, hi, Daniel. This is Vinay. Can you hear me?
Hi, Vinay.
Thanks for a wonderful presentation. I was particularly interested in your research on citation network analysis. Could you throw a little bit of light on exactly what you're trying to achieve with, especially analyzing citation networks? I saw PubMed and another one from Microsoft, if I'm not wrong. So exactly what is the research on?
So there are many things. So one of the most obvious ones is try to do link prediction. So if you think about it, a network of citations, the nodes are the papers and the links are the citation. Sorry, the edges are the citations. So there is this entire field called edge detection, where we could detect edge prediction. So we could try to detect citations that are missing. So that's very important. It turns out that a lot of fields in science are very siloed and they're very kind of into their own topic. So it would be interesting to apply basically techniques from AI of link prediction to these citation networks. That's one thing. The other thing is to try to use the citation networks to do other kinds of embedding. So we already know embedding from natural language processing from abstracts, but if you think about it, we can also do an embedding of the citation network just based on what are the papers citing, and through that the embedding might look different. So maybe in the text they're saying we use these techniques, but through the citations, maybe we're saying something different. Yes, we use this language, but we are really citing this other language, so that we might find differences there. And lastly, I will say that there's a huge opportunity for biases too. So a lot of times there is research showing that we tend to cite we have a huge bias for citing certain genders, certain races, certain countries. So there's a huge opportunity in the citation prediction to try to correct that and maybe nudge people to cite perhaps other people, other scientists.
Got it. Is there like another opportunity of probably predicting the progress of scientific discovery over time based on these embeddings and analysis that you do? I feel that was a little interesting.
Yes. So in fact, if you think about it, this idea that I was talking about here of kind of trying to understand the novelty, like what is the space, you kind of embed the papers perhaps on the citations. Well, we can use these measures of novelty to try to predict what will be novel in the future, right? So if you think about, okay, how would this network of citations evolve over time? You can try to think about, okay, what will be novel, let's say a year from now or 5 years from now, and you can use the temporal evolution of citations to try to get at that question. Yes, absolutely. Thank you for your question.
Hey, Daniel, thank you for your presentation. So I come from like a more information extraction background, and I was just wondering what you're doing in terms of like extracting from like natural language, how you extract facts, and like what is the status of that?
Yeah, that's also like a very active area of research. So I mentioned name entity recognition, but first, of course, to do that, you need to detect the entities that are present and the relationship between the entities. So there is a huge there's a huge interest in this space. In fact, I'm part of a conference, and I forget the name of the conference because it's like a workshop that happens in different conferences. So there is the workshop is called Scholarly Document Processing, and they have these competitions, and they have data sets for exactly the question, your question of trying to detect entities in scientific publications. So there is, I think there is so much that we can do in that space. If you think about it, the most common way in which we share information and relationship of what we find in science is just through text. So, but none of that is manipulable. There is no like sequel to say, okay, how is this concept related to another concept? So, yeah, there's a huge opportunity there.
Okay, thank you. And also, just like out of curiosity, are you more interested in developing methods? So is it like the overarching goal of science of science, or is it more like the building blocks? What are you more interested in?
What a great question. I don't know the answer to that. That's what I've been wondering over the last 5 years. I guess I'm moving to a computer science department because I'm interested in the big questions. Okay, how does science progress? But for a long time, we have been able to answer those questions with citations only. So this is very abundant information that we have, but there is so much more information, again, available in the text, in the images. So I guess I'm trying to develop methods as well at the same time to answer questions more precisely and other kinds of questions. I don't know if I answered your question, but I want to do everything.
That's perfect. That actually works a lot. Thank you so much. Yeah. Those are my major questions.
Thank you.
I guess no questions. Going once? Okay, there is one in the chat. Oh.
Read your presentation. So that's a great question, Rohan. We don't really know how these biases are introduced. One of the obvious ways in which these are introduced is through just the language use. So basically, when people talk about some discoveries or some concepts, they might use gendered like some gender pronouns, and that's how they find relationships. So what I show you here is basically how is the embedding of this. I guess this is the most bias. So how is the embedding of expert bias against female? Because usually we say he's an expert, or the expert is him, or so this system is basically learning kind of occurrences of words in scientific papers. So that's one way in which it's happening. Another could be just basically that we are paying attention to some kinds of scientists, and there's just a social bias. So research that is happening in the West, maybe in English-speaking countries, is much more prominent, and therefore you will get the other kind of bias here. So in which white or European-based names are more commonly associated with concepts that are scientific. Thank you for your question. Good question, by the way.
Yeah, hi, Daniel. I have a quick question. And first, that was a really nice presentation. Thank you.
Thank you.
So I think it was maybe your first slide or way early on, you had a diagram with a bunch of different steps in the scientific process. And one of them was knowledge discovery. You spoke about a lot of applications in the other bins, I think, like the review and correctness, especially, but kind of what do you consider knowledge discovery, and what applications in knowledge discovery are you interested in? Yeah,
that's a great question. So, and it's a little controversial. So like philosophically, some people feel that you cannot really discover knowledge. Like these are like novel things that are really impossible to predict. But there is some evidence that, let's say, things that are going to be really prominent in the future might be things that are disruptive. For example, things that kind of that you can say are going to be using new methods, and they're going to be really different. So I guess the knowledge discovery is more like, okay, how can we kind of understand the limits of what we know? Like what are the kinds of concepts that are very novel at the moment, but also related to the second, I guess the second column here, you want to understand, okay, there could be things that are novel that are crazy, right? Things that are not really going to go anywhere. So you can think, well, we also want to measure how impactful those things are going to be. Okay, so that's typical definition, perhaps from more economics. One things that are perhaps going to end up being technological advances. So and there is some evidence that you could be able to predict those things, but not like with amazing accuracy. But I think there is a huge opportunity to start to see how things are being born in science, because science is usually one of the earliest places where these new ideas show up. So I guess that's what I mean with knowledge discovery. That's kind of the higher level. To me, there is like a lot of work also to be done on just basic search systems. So we usually think of Google, but Google is optimizing for click-through, but in science, we really want to optimize for other things. So I think there's a huge opportunity for search systems, for recommender systems in there too.
Great, thank you so much.
Yeah, thank you. And there's another question by Seung-wook Ali. I thank you so much. The data label is very important. So that's another very good question, because for a lot of these methods, you need to learn from data. And for a lot of the things that I talk about, you don't have label data. So for some of, let's say for the research integrity stuff, I build just pipelines for labeling data, and I recruit experts. There is no way around it. That's how Tesla is doing it. They have a massive operation for labeling streets and signs in streets. So I kind of borrow the ideas from there. I have, a massive army of people that are going through to items and labeling them. And, so through a combination of kind of fine-tuning methods that other people have used. So for example, we use the YOLO deep learning architecture. We fine-tune it a little bit so that we can detect some kinds of graphs, and it works relatively well. So sometimes you also need to be more creative and be willing to kind of pay the price of accuracy by maybe doing some distant labeling. You don't have the label exactly what you're looking for, but maybe you can look at ways of looking at like neighboring concepts that you can use as labels for your task, things like that.
Okay. Now it seems to be quiet, so I think we can
Yes.
call it a day. Thank you once again, Daniel, for your presentation and for your time. Actually, this is very valuable for our students. So thank you once again.
Yeah, thank you. Thank you, everybody. And please, again, send me an email or stop by my office if you want. Thank you. Thank you for the invitation. Bye.